بسم الله الرحمن الرحيم رب زدني علما.
Now, in terms of BGP, this is not like OSPF or EBGP, especially the neighbors here. Like in the previous, we have discussed there are two types of neighbors. We have internal BGP neighbors, if both the routers are in the same AS. If the routers are in different AS, then we call them as external BGP neighbors. So first, we'll try to see the internal BGP neighbors. Internal or external, the neighbors has to be manually configured. Now manually configured means, if you remember, we did OSPF and EBGP, how they work. Whenever you advertise this network, whenever I go and say network statement on this interface, it will send out a hello message on multicast. And whenever you advertise the same thing, network statement on the router 2, it will listen to that hello and reply back with a hello message. And automatically they listen to each other hellos and they become the neighbors. So this is what we call as multicast or dynamic neighborship, or by using the neighborship establishment using a multicast, because the hello messages will be sent on the multicast address. But whereas in BGP, it's not like that. In BGP, you cannot say that I'll go and advertise this interface. They don't form the neighbors. We have to manually configure. We need to go to this router, and let's say the IP address is 1.1.1.2. So we have to give the neighbor command on the router 1. And also we have to give the neighbor command on the router 2 to form the neighbors. We call this neighborship as unicast neighborship. So in the unicast neighborship, we are going to manually configure the neighbors on both the sides, and manually we have to configure, because as I already mentioned, if you remember, we don't want to run BGP on every router. We want to run on selected routers, and the neighbors also will decide which routers you want to form the neighbors, which routers you don't want to form. And once we are done with this configuration, we can use show IP BGP summary, show IP BGP neighbor commands to verify the neighbor table. We also verify with BGP tables later on, like show IP BGP with attributes. We'll see this later on. Routing table is same as your best routes. So we'll talk about this BGP database, BGP forwarding table, probably a little bit later on when we get into the attributes. So let's try to see the configuration wise. There are specific configuration commands we'll be using here. So I do have this 4 routers topology. So I'll be using these 4 routers. Already I have started these 4 routers, and you can see the console. Now what I want is, I want to configure the BGP between these routers. Again, as I said already, even though you might be having hundreds of routers, maybe you have hundreds of routers, inside the AS, these all routers will talk to each other with the help of any of the IGP protocol. Only on the selected routers will be running BGP. Let's say maybe these 3 routers. So we need to configure the IBGP neighbors between them. So in my case, I'm assuming these 4 routers are connecting to 4 different customers, and I want to run IBGP between them. So we'll talk about EBGP a little bit later. First, we'll start with the basic IBGP configurations. So in terms of configurations, so we need to start with the configurations, like we start with the router BGP, and we must give the AS number here. Now remember, this AS number is something you get from the INA or you get from the service provider. Now you cannot go and say, I will use whatever the number I want. That's not possible. So this number has to be the exact number given by the service provider. So let's assume that I was given as 500, let's say. And then we need to give the neighbor command. Like in my example, I want the router 1 to form the neighborship with router 2, and the router 1 to form the neighborship with router 4. So there are 2 neighbors I want to configure. So manually you have to do this with the neighbor command. We say neighbor, what is the IP address of the neighbor? 1.1.1.2, and then we have to give remote AS. That neighbor is in which AS? Now I'm 500 and I want the router 2 also should be in 500, everyone in 500, okay? So now this neighbor is in 500 also, which means I must give 500 here. So whenever you are doing this configuration, if my AS number, this is my AS number, and the neighbor AS number, if these two numbers are matching, if it is same, then the router will automatically understand that it is an internal BGP neighbor. If my number is 500 and the neighbor AS number, let's say 600, then the router will understand that it is an external BGP neighbor. So the only difference between the internal BGP configuration and the external BGP neighbor configuration is the remote AS number. So if I'm using the same number, then it is a local, that is your internal BGP. If you're using different number, that is external BGP. So anyway, right now I'm using 500 for all. Later on, we'll also see external BGP later on. So what is my another neighbor? My another neighbor is 4.4.4.1. Remote AS is 500. Now again in BGP, when we are doing advertisements, we only advertise the public IPs most of the time. Here I'm going to advertise all my networks. Let's say there is a 10 dot subnet where I have some networks. 1 dot network is not compulsory to advertise, but in this example I'm going to advertise these networks. But again, remember, advertising this 1 dot network or 4 dot network have no significance here, because normally in OSPF what we do, we advertise this network and this network so that they automatically send hellos. But here it's not like that. So the neighborship establishes based on this, not based on this network statements. So the network statements have no significance unless you want them to advertise in BGP here. Just to make my BGP table bigger, I'm just advertising them. Now there is one more thing you need to know while doing advertisements. Network, let's say there is, if you just try to see here on the router 1, I have this loopback. I want to advertise this loopback. So I cannot go and advertise like this. Now the problem here is, now this is wrong. So if I go and say network 11.0.0.0, this is wrong. But again, you can say that, okay, what about this one? Here I have given, that is correct. So network 10.0.0.0, that is correct, but this is 11 dot is wrong. Now we need to understand what is the difference between these two. So let me explain you here. Now normally what happens is, whenever a BGP you give network statement, it is going to check the routing table. It is going to check the routing table. And in that routing table, you must have exact subnet in the routing table. Now the 11 dot network, if you see here, there is a 11 dot network, 11.0.0.0, this one. We have this 11 dot network. What is the mask over there? The mask here is 11.0.0.0/24. And whereas if you check the 10 dot network, what is the mask here? /8. So basically what happens is, whenever you are giving the network statement, by default, if I'm not giving anything here, which means I'm advertising the 10 dot network, it is an A class, so automatically it will advertise with /8. So even 1 dot network, 4 dot network, they are A class, they will be advertised automatically with /8. Same thing applicable here as well. When I'm advertising the 11 dot network, it will advertise with a /8. But the problem with the BGP is, BGP always check, whenever you give any network statement, it will check the routing table to match the selected exact route. if the exact route is present in the routing table or not. Exact route means exact slash value. So in this example, if you say show IP route here, the 10. Network advertisement will accept, because when I say network 10.0.0.0, it is /8. So it matches the exact route in the routing table. But whereas in the 11. Network, there is a 11. Network with /24. So there is a mismatch. So you're actually advertising with /8, but in the routing table, it is /24. The BGP will not advertise the routes. So this is one common mistake we do. BGP will only advertise the routes if that route is present in the routing table, either in the form of connected or in the form of OSPF or any other routing as well. But it has to match the exact network along with the exact slash value. So you must have the exact route present in the routing table with exact slash value. So that's the reason whenever you are advertising any network which is not using the default mask, like here, we must use the exact mask with this mask option. So which means I'm saying that now advertise this 11.subnet with /24, which matches the exact route in the routing table. So it has to match. So this is one kind of condition in BGP. So there are plenty of conditions you will see later on as we progress. So this is important to know. So BGP only advertises the routes if the same route is present in the routing table. If it matches or if it sees the exact route in the routing table with the exact network ID and the exact slash value. So that's the reason whenever you are doing advertisements, make sure that you are advertising with the exact mask, not like EBGP. If you remember in EBGP, if you just simply go and say network 11.0.0.0, automatically all the networks which starts with 11 will be advertised. Same with OSPF with wildcard mask, same with RIP, but here it's not like that. Okay. So this is one more additional thing you need to know when it comes to configuration examples. The same example. Let me quickly do the same thing on the router 2, router 3, and the router 4. So I'll quickly do the configuration here. So router BGP 500. So on the router 2, I'm peering with two neighbors. So let's say neighbor 1.1.1.1. The remote AS is 500, and the neighbor is 2.2.2.2. Remote AS is 500. Advertise your networks. I'm not using loopbacks here. You can see the neighborship comes up. And on the router 3, so this example will give the basic idea on how to configure the neighborship. Okay. Of course, there are other best practices we follow later on. So the router 3 is peering with this one and this one, right? So we'll say neighbor 2.2.2.1. Remote AS is 500. And the neighbor is 3.3.3.2. Remote AS is 500, and then advertise your networks. WAN interfaces are not compulsory to advertise, but here in this lab you have to advertise. Again, we'll see that. Now moving to router 4. Router 4 again peering with these two addresses. These are my two neighbors. We'll say neighbor 4.4.4.2. Remote AS is 500, and then neighbor 3.3.3.1. Remote AS is 500. So if you advertise 40.subnet, and then 4.subnet, and then 3.subnet. So this is a kind of simple basic example or basic neighbor configurations. Now the main thing you need to keep in mind when you're doing the configuration, this number has to be given by the service provider or the INA. And you need to type the IP address of the neighbor. And if these two AS numbers matches, the router will understand it is an internal BGP neighbor. If not matches, then it will understand it is an external BGP neighbor. So right now we have configured two neighbor commands. Network statements as it is. If you want to advertise with the default mask means like A class /8, B class /16, C class /64/24. So you don't need to give the mask. And if you want to advertise any network other than default, like in this case, I want to advertise 11.network with /24, we need to give the mask option. And one more thing we need to remember, whatever the network statement you give here, this exact route must be present in the routing table, whether connected or whether OSPF, then only BGP will advertise this route. So if you don't have this route in the routing table, and if you are trying to advertise that route, then BGP is not going to advertise those routes. So that is again another condition we need to keep in mind while we are doing these configurations.